Hi everyone, my name is Sindhuja, working as an assistant professor in the Department of Cybersecurity and Data Science in MLR Institute of Technology, Hyderabad. I welcome you all with another video on the effect of time. So the overview of today's presentation is the effect of time with respect to stream data. Okay, the effect of time we can calculate in two parts. The first part is computing on a time-stamped events and computing with a watermark. What are this computational process and what is the effect of time with respect to computing? We'll discuss further. Now we'll look into the first topic. So event time processing. Okay. So with respect to stream data, as the data is continuously coming into the data source. So event time processing refers to looking at the stream of events from the timeline. Okay, which means that based on some time intervals, we can calculate the events, number of events in a stream. So at which they were produced and applying the processing logic from that perspective. When we are interested in analyzing the patterns of the events data over time, it is necessary to process the events if we were observing them at the time they were produced. Okay, so capturing the number of events from a continuous flow of stream is very easy with respect to time. To do this, we require the device or system that produces the event to stamp. Okay, so counting the number of events with respect to time requires some devices, right? So based on some device time only, we can store the event time. So for that, we require timestamp. The events with the time of the creation. Okay, we can call it as the timestamp is nothing but the event at which the time is created. The usual name timestamp. We can call it as a timestamp to refer to a specific event bound time. So the time at which the event has generated. We use the time as our frame of references for how the time evolves. Okay, we can use that time frame to generate the time. So if we take an example here, I have taken weather data collection. So to collect the weather data, we require one device. So which stores the sensor data and which can give accordingly. Weather stations. Okay, we have multiple weather stations in real world. So those weather stations sends data through networks with different speeds and reliability. So each and every device may connect through network and those events and those data can be generated with respect to network via multiple devices. Data may arrive out of order. Sometimes we can say that all the devices generate the data in a proper order. So each station adds a timestamp to its events. So suppose if we take one weather station, okay, this is, I can call it as a central weather station. Okay, central weather station, from which I can get all the weather stations, other weather station data, and I can monitor. So this is one station, this is another station, this is another station. So like that, if one central weather station is connected via multiple weather stations, so from each and every station the data is generated in the form of events, in the form of continuous form to a central weather station. So each and every station has put some timestamp. Okay, put on timestamp on which the data generated, on which the data has generated in terms of events. Okay, so event comes with timestamp. From every station, events comes with timestamp, so that it is easy for us to recognize from which station how much data has created on which time. Okay, this kind of processing is nothing but event time processing. The system uses these timestamps to perform time-based calculations for forecast. So other systems can use this kind of timestamped events for weather forecasting, as is predictions. So now we'll look into the first topic of event time. So there is an advantage in keeping track of the intermediary data long as keep intermediary data in a bounded and limited size. Okay, what is the advantage of keeping intermediary data means with respect to time, if we can store the data, we may have to get the chance of overlooking the data into deeply. and we can store with respect to size as well. We want to consider another issue unique to stream processing, which is the operation on time-stamped messages. Here we are working with the stream processing engine and on continuous flow of data, which means that data streams we can call with time stamped messages. Why? Because the data is generating on a continuous basis. So to capturing that data with respect to time is an easy task. So computing on time stamped events. Okay, so here I'm just integrating timestamp with each and every event. Elements in a data stream. Okay, in one data stream, all the elements always have a processing time. Okay, all the elements have their respective processing time. Processing time is the time at which the stream processing system observes a new event from a data source. So the stream processing system works as an intermediary device in between data source and data sink. Data source is nothing but input device, we can say. Data sink is nothing but output device, we can say. In the middle of this, there comes stream processing engine. Okay, so processing time is a time at which stream processing system observe a new event. Okay, a new event comes to stream processing engine, which is nothing but we can call it as a processing time of this particular stream processing device. Event time is a time when the event is actually happening. Okay, there are two types of events with respect to time. The first event is processing time and event time. Okay, the time at which the event is processed. Okay, the time at which the event is generated. Okay, the event is generated. The time is usually added as a part of the message element in the stream. So for each and every element and each and every message is going to added to each and every element. Time stamping is an operation that consists of adding a register of time, clock or system time at the moment of the generation of the message. Okay, here time stamping is nothing but adding time frame to the event of all the elements. Timestamps. Timestamps as a provider of the idea of time. Okay, we can calculate timestamps as the idea of the time. Okay, the importance of timestamping is it allows user to understand the day by considering the data by considering the moment at which okay, now we'll see what are the timestamps here. Okay, timestamps as the providers of the idea of the stamp. Okay, here we are using timestamps as a time measurement. Okay, idea of time measurement. So the importance of timestamping is that it allows users to understand the data by considering the moment at which it was generated. Okay, the timestamp, the idea of timestamp concept is nothing but it allows the user of the data to understand it first and considering when the event has generated. Okay, when the event has generated and data has generated with respect to time. Timestamps helps make sense of what happened to a particular system at a given time. Timestamps also helps the systems to have the clear verification of all the systems with a given period of time. The cluster that processes the data is an operation prone to different forms of failure in which some events could be delayed or reordered or lost. So in this process, in the cluster of processes, there may be chances of losing the data and there may be chances of delayed or reordered of events. So user of a framework such as Apache Spark want to compensate for those problems. Okay, so here by using Apache Spark we can compensate this kind of problems. Means we can remove this kind of problems which are delayed. What are the problems associated with the processing of all the events at a time? Delayed or reordering of events. There may be chances of delays, reordering of events and losing of data. So all these concepts are here are failure concepts, right? So these we can compensate with the Apache Spark fault tolerance, which we have discussed in earlier classes, right? So which is nothing but fault tolerance. Clearly mark by using Apache Spark framework, we can clearly mark corrected and reordered results. We can mark clearly which are correctly ordered and which are reordered. Expected intermediary results. Okay, we can again predict expected intermediate results. Next, in Spark, this feature is offered only by structured streaming. Okay, in Spark, it is provided by structured streaming. Okay, in Apache Spark, we have two types of streaming. One is Spark streaming and the one is structured streaming. So, it is possible only by structured streaming concept. Now, we are going to discuss what is event time and what is processing time. There is a timeline in which the events are created and the different one when they are processed. Okay, there is a time gap between event is created and event is processed, right? So, which is nothing but we can call it as a timeline. Okay, timeline. Event time refers to the timeline when the events were originally generated. Okay, the time at which the event is generated is nothing but event time. We call it as a event time. A clock available at the event generating device, especially from where we can get this event time means a clock which is available at the event which is created by the device. Okay, we can say that the device which is creating that particular event is nothing but that event time device, a timestamp in the event. It means that all the events from the same source could be ordered even in the case of transformation delays. Okay, if multiple events are generated from the same device, so those all are generated in a ordered wise. Okay, ordered wise. We can say that all the events are generated via in a particular order. Processing time is a time when the event is processed by the stream processing engine. Okay, stream processing system or stream processing engine. The time at which the generated event or event timed data has processed is nothing but we can call it as a processing time. So here if we look event time individually in terms of a diagram, if you can see here, this is nothing but event time window. It will represent event time window. So now consider 10 seconds window. Okay, as we have discussed in the yesterday's topic, I mean windows, sliding window and tumbling window. Event times are displayed with respect to windows. So here we can see that 10 seconds window here defined on an event time. Okay, what is my event time? 10 seconds window. Okay, my window time is 10 seconds. In this case, we use the event creation time as a window aggregation criteria. Here, we can use that, event generated time as window time. Okay, window time. So, these windows look different from the processing time windows. Okay, here we can see in this diagram, the window at 0 to 30 seconds. Okay, 30th second to 40th second contains all the events that were created in that period of time. Here with respect to event time, here x-axis represents event time, y-axis represents processing time. Okay, here with respect to event time, the event has started at 0th second. Okay, the event has started at 0th second. Here at the time, the events at the particular time here, which is 30th second to 40th second. Okay, 30th second to 40th second, which is nothing but my 30th second to 40th second, which is nothing but I can consider this limit as event time. I can consider this boundary as event time. Okay, with respect to the timestamp. We can also see that this window has no natural upper boundary that defines when the window ends. Okay, here there is no natural upper boundary for this. There is no boundary for this window. The event created at 0 to 36th second was late more than 20 seconds. Okay, here if we can consider 36th one, Here 36th second. So it was a little bit late. The event was little bit late with respect to event time. Okay. As a consequence, to report the results of the window 30 seconds to 40 seconds, we need to wait at least 1 minute. Okay. We need to wait at least 1 second. What if an event is dropped by the network? What if the network is dropped and never arrives? How long do we wait? Okay. How long do we wait for the next, after late event, how long we have to, wait to solve this problem? So instead of waiting for the next event to occur, to solve this problem, we introduce an arbitrary deadline, that is nothing but watermark. Okay. To solve the late arrival of data, we can introduce a topic called watermark to deal with the consequences of this open boundary, like lateness, ordering and duplication of the data. Okay. To handle this open boundary data, lateness data, ordering data and duplication of the data, deduplication of the data with respect to watermark. Now let's move on to the processing time. So we start by considering windows defined on processing time here with respect to this diagram. The stream processor uses its internal clock to measure 10-second interval. Here the stream process uses 10-second interval for calculating processing time. All events that fall in that time interval belong to the window. Okay. All the intervals with respect to this 10 seconds, we can call it as one window. Okay. With 10 seconds gap, each and everything is called as a window. Okay. Horizontal lines, here the horizontal lines defines 10 seconds window. Okay. Here the horizontal lines defines 10 seconds window. This is 10-second window, 10 second, like that, and so on. Next, we have also highlighted the window corresponding to the time interval 30 seconds to 40 seconds. Okay. It contains two events with event time 33 and 39. Okay. With respect to 30th and 40th second, if we calculate between these two timelines, here how many events has happened with respect to event time means there are at time of 33rd second and for 39th second, two events has happened. The rounded one shows the event. So two events has happened. Okay. So we can calculate the processing time for those two events. In this window, we can appreciate two important characteristics. The window boundaries are well defined. Here we can see the window boundaries are well defined, and we can see in this highlighted area. For example, although we would assume that 30th to 40th second window would contain the event 36, we can see that it has fallen out of the resulting set because it was late. So if we can consider 36th second event has generated and it has fallen out. Okay, it has failed to captured by the system. So we can call it as a late event. Okay, the event which has late for processing. Okay, we can call it as a late arriving event. Now, if we can look into the event time and processing time in a combination, here if you can observe on this diagram, here event time works with respect to processing time. So then we can calculate by using these two, we can calculate perfect processing time line. Okay, perfect processing timeline which represents with a diagonal. Okay, here which represents with a diagonal. Okay, now here the x-axis represents the event timeline and the dots on that axis denotes the time at which each event was generated. Here on x-axis, if you can observe with dots, all these are events. Okay, the y-axis is the processing time. Each dot on the chart corresponds to x-axis is a processed. Okay, here if you can observe here with respect to processing time, all these are events again which are processed. Okay, next, for example, the event created at 8th second, first on the x-axis is processed. Here if you can observe at the 8th second, one event is generated. Okay, here one event is generated, is processed at approximately 12th second. Okay, with respect to processing time, if we can calculate perfect processing time with respect to x-axis and y-axis, these both are intersecting here at this point. So here which is nothing but the perfect processing time. Okay, the diagonal shows perfect processing time with respect to event time and processing time. The diagonal line represents the perfect processing time. In an ideal world, using a network with zero delay, events are processed immediately as they are created. Okay, here there is no delay. Okay, we can call this is a zero delay line or perfect processing time. There is no delay within a 1 second also. Perfect processing time we can call. Now, next, the vertical distance between the diagonal and the processing time is a delivery delay. Okay, here another factor is there, which is nothing but delivery delay. Okay, how much delay has happened with respect to event, with respect to generated time and processing time, means we can calculate from perfect processing time to that particular event which it has processed. Okay, so this gap is nothing but delivery delay. So this much delay has happened with respect to processing. Now the next concept is computing with a watermark. So watermark, as I have told you that in the previous slide we have seen, watermark is nothing but out of the boundary, and next deduplication, open boundary, which means that here, and all these data are handled by watermark. Stream processing produces periodic results out of the analysis of the events observed as its input. Okay, sometimes there is a chance of out of the order events. When equipped with the ability to use the timestamp contained in the event messages, the stream processor is able to bucket those messages into two categories based on the idea of the watermark. Okay, so with respect to watermarks, those delayed events, reordered events, or any other deduplication events are marked with respect to watermark into categories. Okay, based on some categories we can divide and we can process it through watermark. A watermark is applied to timestamp column. Okay, watermark we have to apply on timestamp column in a streaming data frame. Okay, here watermark works with respect to timestamp again. Okay, watermark works with respect to timestamp in data frame, specifying a delay threshold. Okay, here watermark represent delay threshold. We can say how much delay has happened while generating the event. So we can call it as a delay threshold. This threshold determines how long the system will retain state for late arriving records. Okay, this delay threshold will determines how long the system will retain state for late arriving records. So those late arriving records, the system how long it is going to restore. For example, here if we can see with a small code, here I have added watermark on my data frame. So watermark is it is a combination of timestamp, right? So here in the watermark I have taken event time of 10 minutes. What is the timestamp for watermark? 10 minutes. And here this is tumbling window. Tumbling window means this is the movement of window for every 5 minutes. Okay, movement of window by using tumbling window concept, it will go for 5 minutes. It will process for 5 minutes. Okay, here if we can see this example, the 10 minutes watermark is applied to the event time. Okay, as I have told you, watermarks work with the timestamp. The 5-minute tumbling window groups data for aggregation. So okay, for every 5 minutes tumbling window groups the data. Okay, for every 5 minutes it groups the data. State is retained until the window is 10 minutes. Okay, state is retained until the window is 10 minutes older than the latest observed event. So for every 10 minutes, even though the tumbling window is time is for 5 minutes, for every 10 minutes the window is retained, restored with watermark timestamp. Okay, even though the tumbling window is showing 5 minutes, the previous 5 minutes also retained, which means that we are storing late arrival of data, reordered data or deduplication data with respect to watermark. Here the use of watermark is nothing but without losing the data, it will store the previous data as well in the form of retainment. Okay, two categories based on watermark. So there are two categories which are based on watermark. The first one is the watermark is at any given moment the older timestamp that we will accept on the data stream. Okay, here the older timestamp is also added. If this is the current timestamp, the older timestamp is also added as a watermark. That is the first category. And the second one is any events that are older than this watermark are not taken into processing. So any events older than watermark. So if the watermark time has completed, it will not consider the previous data. It will not consider the previous data. These are two categories on which watermark works. The stream engine can choose process them in an alternative way, like report them in a late arrival channel. For example, to account for possibly delayed events, this watermark is usually much larger than the average delay. Okay, sometimes there may be chances of watermark delay is greater than average delay. Okay, average delay. If you can observe here, watermark is represented with red line here. Okay, this is nothing but watermark. So, the system considers all the events which is up to watermark and perfect processing timeline. Okay, the system consider how many events has to be processed means the events which are in between watermark as well as perfect processing time. So it can retain the data in the form of watermark. Okay. Next, when we apply this concept of watermark to our event time diagram, it is showing here. We can appreciate that the watermark closes the open boundary left by the definition of event time window. Here you can see that watermark has closed. Yes or no? Here watermark has closed this open boundary of event time. Okay, watermark is closed. So here we can count this as a total number of events happened. Total number of events generated and processed. So there is no open boundary. Why? Because watermark has closed that boundary and it is showing the limit of the events. Okay, limit of the events or size of the events which are going to process. Providing criteria to decide what events belongs to the window. Okay, it is showing that how many windows are belongs to how many events are belongs to that particular window, like a closed boundary. With respect to watermark, we can calculate the one window size and what events are too late to be considered for processing, and we can also differentiate between the events which are belongs to one specific events or belongs to the specific window, and all the other events which are not processed and which are not perfectly processed on time. There may be chance of late. Okay, so we can differentiate between the processed events as well as unprocessed events by using watermark concept. So this is all about processing of streaming data with respect to time, and how we can calculate by using the event time and processing time and timeline with respect to both. So as the data is continuously flowing in a stream processing, to capture all the events with respect to time is a very easy to manage that kind of real time data. So that's all for today. Thank you.